good to be a part of DDD, and yeah, it's in the early hours of Sunday morning here where I am in Adelaide, South Australia, but I believe it's afternoon there in the UK. So just a reminder of the code of conduct, and just to be respectful and patient friendly, understanding, kind and considerate. I'm sure you're all of those things already, so but yeah, it's good to be reminded of that. Just a reminder as well about the cause that is being supported this year, the National Museum of Computing. So it'd be great to get behind that. And we do appreciate the sponsors that help put on an event like this. So for Microsoft for the giveaways, for Black Marble for organisation and volunteers, other sponsors, donations, so IO Associates, Grey Matter, NDC London, coming up in January next year. And yeah, feel free to tweet, and DDD 2020 is the hashtag. Okay, I'm going to switch over to the talk, the opening slide. Harder, better, faster, stronger builds. So I'm not going to sing Daft Punk. I'm sure you're relieved to hear. But yeah, I guess quickly a bit about myself. My name's David, obviously. I'm a senior developer here in Adelaide, South Australia. I work for a company called RL Datix on healthcare software. They actually have offices globally, including in the UK. And I guess over my career, I've always seemed to be the person who's ended up working on the build system, sort of maintaining build servers, writing build scripts, deployments, all those kind of things seem to be sort of, that would sort of fall in my lap to work on. And so in doing that, I've ended up with, I guess, a few war stories, a few experiences that things haven't always worked out well. So that's what I've drawn on for this talk to give you now. So we've got some software we've written, and we want to be able to build it, and we wanted to be able to deploy it reliably. So let's go through and find out some ways we can do that and some things to watch out for that might stop us from doing that. One thing to keep in mind is this nice little quote from Leslie Lamport: "A distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable." And the thing about that is that often when we do builds and deployments, there's more than just our own computer involved. There's often a whole lot of computers, and some that you weren't even thinking about. So often it's that computer that you didn't even have on the radar that is the one that causes a problem with your build. So, all right, so we've got some software and we want to build it. Well, how can we do that? Well, we could use the GUI. So we might have an IDE like Visual Studio or Eclipse or some other IDE, and we can build our software from within there. And that's okay, particularly if it's a really small application that say just you're working on yourself. It might just be a throwaway app, but you might want to take it a step further and make it a little bit more organized. So you could just do a command line build, have some commands that you can run from the command line to automate the build a little bit better. Or take it even a step further and create a proper script. So it could be a bash script or PowerShell or some other scripting language that we've actually listed out a few things we need to do to actually run the build. That's a bit better. Or we could even introduce some kind of build orchestration tool. And so things like Passaic or Cake or some other DSL that's specialized in automating builds. So for example, Cake is one that I quite like because it's based around the C# language, which I tend to use for a lot of my development as well. Here we've got a script, and we're able to define what the specific tasks are that we need to perform when we're building our application. So we've got a clean, a build and a test. We can set up our dependencies on those as well, so that we when we're running our test, then we want to make sure that our build is done first. So using a DSL, like a language like Cake can allow us to be a lot more descriptive and in the kind of building that we need to do. So it's not just going to be a simple build within Visual Studio, for example, but there's a whole lot of other steps we need to do as well, and we can incorporate into a Cake script. Something else we might want to think about is package management. So often when we're building software, there's a whole lot of extra things we want to include in our application, and not all of these are things that we've written ourselves. We could just get all the DLLs or the binaries or assemblies, commit them into source control and just reference them directly. But often there's some kind of package management solution that we could use instead that makes that process a little bit easier to manage. So things like NuGet or NPM are examples of that. So if we're using NuGet or NPM, it means we just need to define the name of the package and the version, and we can include that in our software. But there's some gotchas that can happen with that, which we'll look at shortly. So the nice thing about that is it also means we can even use that in our own software. It's not just third-party dependencies. If our application is really large, we could actually break it down, generate packages, and then consume those packages elsewhere in our software, which means our compilation might be a lot faster because we're not having to recompile everything. We're just compiling particular source code, and all the other packages come in, say, pre-compiled if it's a compiled language. But how do we make sure we're using the same versions of everything? Well, lock files are one way of doing that. So because you wouldn't want to have, say, a NuGet package where different developers are doing builds on their own machines and they're all getting different results because it's bringing in different versions like 2.1, 2.2, 2.3. So if we introduce a lock file, then that means we can be very explicit about what version of a package we want to consume. And it just makes the build a lot more repeatable, and it's going to be the same experience for everyone. So most package management environments have a concept of a lock file. The important thing is to commit them into source control as well. One gotcha that I've discovered is with NuGet, that the lock files are platform specific. So if you're targeting different runtimes, so Linux, Windows, Mac, then the lock file actually will include references to those platforms. And that can be a problem if you're doing a build on one platform and then trying to deploy it to another platform. So make sure that you're letting your build know that you're going to be targeting all these different platforms. Things to watch out for are what happens if a package disappears. And so some of you might be aware of a few years ago, there was the LeftPad NPM package that the developer there decided he didn't want to keep doing it anymore, so he just deleted it. If we've taken a dependency on a package, how can we ensure that we are not going to break our build if that package suddenly appears off of a public repository? So you might want to consider using something like a package aggregator, say MyGet or Azure Artifacts, which then keep copies of all those packages that are coming from upstream. Also, what happens if they go offline? Just take NPM, for example, and if you have a look at the status for NPM, you'll see that it's not up 100%. They might have a scheduled outage or an unscheduled outage, and likewise with some of the other package ecosystems. If your build is assuming that package resource is there all the time, then you might be in for a surprise when sometimes your build fails because it can't access those resources. So introducing an aggregator might be one way of dealing with that, but even that, it may not be robust all the time. So your build may have to deal with the fact that things may not be there all the time. So whether that means your build fails or you put in retry loops to handle that situation. Other things that can happen are things like changing the configuration of package environments. So here's an example where NuGet changed their TLS, so their network encryption, to dropping support for TLS 1 and 1.1 earlier this year. So if your build's tooling had the older NuGet client, all of a sudden that would stop working. So that's, again, something that happened to me where I had to go in and update all of our builds to make sure we're using a newer version of the NuGet client so that we could still pull down those packages. And that can be a problem, especially if you've got a lot of release branches. You're going to have to go and update all those release branches with the newer tooling. So another situation you might find yourself in is with NPM in this situation, in this example, where a package, an NPM package, can specify what version of Node it's compatible with. But what happens if you've got two different projects and you want to build both of those on a build system, but they're using packages that require different versions of Node, possibly incompatible ones? Well, that's going to be a problem. It's not going to work. One of those builds is going to fail. So ways around that could be things like having different build environments with a different version of Node installed, or switching the version of Node in some way as part of your build process to make sure you've got a compatible version of Node. What about if there's a tooling regression? And so this again happened to one of my projects I was working on, where the NuGet command, there's a NuGet sources list command, and in a particular version that was released, that output of that stopped working. And we had some scripting that was assuming that that was going to produce a particular output, and all of a sudden it stopped working. So I guess that's a reminder that any tooling you use as part of your build, you really should try and lock down the exact version of that as well. Don't just assume you can always take the latest version of something, because there might be a regression that you weren't expecting. Or even when things like the LTS version, so the long-term support version of something like Node, changes unexpectedly. So another example where we using Docker, and we were pulling down a particular version of Node, and we thought we were pulling down the LTS version. What we discovered was that actually the LTS version, and we thought it was an exact version, but it turns out that the normal way that you'd introduce that into the Docker container, it was actually incrementing that version each time, so it wasn't consistent. So we discovered there's actually some a GitHub issue about this is the way you get the exact version so that you have a consistent build. Yeah. Another thing that you may want to do as part of your build is introduce code signing. So here's an example of some application that has been code signed, and in this case the publisher was Microsoft Corporation, so you can see that when you're getting the prompt in Windows. Some of the problems with code signing that you might need to deal with is who has access to the certificate. Is this something you need to give to every developer, or can we control that and make it a secure thing that we don't have to give out to everybody? So that might mean you need to make the build process allow for building on a developer desktop versus building the release that gets the code signed as well. What happens when the certificate expires? I've seen this happen quite a lot, is that people forget that the certificate has an expiry date, and after that date has passed, you can't use that certificate anymore to sign the code, and the build starts funning because it's trying to sign it with an expired certificate. So basically, make sure you put something in your calendar with a good amount of time as a warning so that you go and renew that certificate. And again, you're going to have to then figure out how do you incorporate that new certificate into all our build process. When we're setting up a build server, we've got some choices to make. And one of those is how much logic do we put into the build server, and whatever kind of language it has to control builds in the build server, versus what logic do we put into our build scripts or cake scripts or those build automation scripts that we're using. And there's a bit of a balancing act there. We can go full on into the build server and use it all there. The downside of that is that it means we can't really replicate that on our own machine. That only happens in the build server. So we need to come up with a balance that makes sense for us. The other thing we need to think about is, do we want to use like a UI to describe our build in the build server, or do we want to use code? So here's a screenshot of the UI in Azure DevOps Pipelines. Or we could go and say use something like TeamCity, where we've got different steps we can add in there and use the UI. The other options with a lot of build servers are to use code to configure our builds. And so in Azure Pipelines here, we've got an example of a YAML file where we've, and it's basically doing the same thing as we saw a couple of slides back. And likewise, in TeamCity, we've got Kotlin, a JVM-based language that they've chosen for their configuration as code. There's some differences in the way these things work. One of the nice things about Kotlin is that you can do a compile of that because it's a compiled language, unlike the YAML file. And so we can instantly find it if we've done a typo because the compiler will tell us straight away. There's some differences though in the way, this is more of a Azure Pipelines versus TeamCity, is that the config here for TeamCity is per project, not per build configuration. Whereas the YAML file, and I guess the same for GitHub Actions, is committed in to the project and is basically per branch. So the nice thing about that is that if you've got that ability, you can make a change to build process and test that out as part of your branch. I haven't seen that same ability in TeamCity, but maybe they're working on that. One thing to be careful of when you do have your build configuration as code is that sometimes that configuration can become out of date. So here's an example of a YAML file for an Azure Pipelines build. And what's happened here is that we've, depending on a particular VM image to run our build on, the trouble is that Microsoft actually deprecated and don't support this VS 2015 image anymore. So that would have worked a few years ago, but you're going to have to go and maintain that and either choose to create your own build agent that has that VS 2015 tooling on it, or test to see whether you can upgrade to a newer image with 2017 or 2019. So there's still that issue that you're going to have to maintain these build configurations because there might be things out of your control that change that you weren't expecting. So our build server needs build agents. Again, we've got some choices to make here. We could choose to have some dedicated agents, so we might have our own hardware or virtual machines that we've provisioned to do our builds. And the nice thing about that is we can benefit from caching. So we've got a machine, the machine is staying around for a while and then builds are running on it. So we can cache things like NuGet packages, Docker images, all kinds of other stuff we can cache on there. The downside of caching is we've got to manage our disk space. Otherwise, our cache may end up consuming all of the space on our disk. So you may have to have a process that goes through at a regular interval and does some tidy up so that you're not caching more stuff than you need. The alternative is transient agents, so agents that appear for a build and then are thrown away after that build. So the nice thing about transient agents is that there's no saved state. The machine is brand new every time, so there's no risk of any kind of things hanging around and messing up your build or making the build behave differently. The downside is there isn't that caching, so a build might take a bit longer. There's a way to mitigate that, and that's to use a cache task. So Azure Pipelines and GitHub Actions have this ability where we can tell it that we're using NuGet or NPM. Here's the folder that we're using, and so when the build runs, it'll realize, oh, you've downloaded all these packages. I'm going to zip those up, store them locally, sort of close to where the build agents are, and then the next time I build, if that cache is the same, I'm going to unzip those onto the disk and save you a whole lot of network traffic trying to download all these packages again. So that can make up in a little way for that difference with transient agents versus dedicated ones. Something else to consider is when we are using a build agent, there's often tooling that we need that need to be in place for our build. So we should look at ways of automating installing that tooling. So that could be using something like Chocolatey or apt-get to bring down the tools that we need to do our build. But again, what happens if that goes offline? What happens if Chocolatey has an outage and we're trying to do a build? Is there a way we can cache those things or have some kind of proxy server in between? There are other things we need to think about. Or do we just go, oh, well, it's offline, but it'll come back online and we'll be okay. There are things to take into consideration. Passwords and auth tokens are something else we need to think about when we're doing our builds. So we might decide, well, we're just going to hard code them. We're going to include the password in our build script or in our code, and we're going to commit that into our source control. Okay, that may be okay, but it may not, because we might be including passwords we don't want everyone else to see. The other problem is that what happens when they expire, particularly authentication tokens tend to have an expiry on them. If we've committed them in our code, it means that that build, we won't be able to redo that build at some point in time in the future when that authentication token has expired. So we need to manage that. Ideally, we're going to track and keep a record of the authentication token expiry date. Just like our certificates, we hopefully have some way to go in and preemptively update those before they all expire. Otherwise, the problem is we're going to have a build that's broken and we have to go in and fix it up afterwards. So ideally, we've got some way of dealing with that proactively. Also, authentication tokens are usually done on behalf of a user. If that user is actually a person in your organization, what happens if they leave the organization? Does that authentication token stop working because their account gets disabled? Maybe you need to create a service account to generate authentication tokens so that it lives on beyond any particular person. Moving on, and databases. Often our applications have data in them, and quite often it's pretty popular for them to want to store that data in a database. So how do we deal with databases as part of our build and deployments? So first of all, there's going to be the whole process of how do we create our database or update an existing database, so the schema migration. And there's two common approaches to this. One is additive scripts, where every time we have a schema change, we create a new script, and that we end up adding more and more and more and more scripts, and you run all those scripts, and at the end of that process, you end up with your database schema. The other option is a schema with a diff, where we essentially have a model database, and we're comparing that using some kind of tooling against our target database, and it figures out at runtime what the difference is, generates scripts to bring that database up to date. There's pluses and minuses with both of those approaches. The additive scripts is nice because you've got that history over time, but as you go on and on, you end up with a whole lot of text, a whole lot of scripts, and they can take a really long time to run. The schema with diff is nice because it can be a lot quicker, but you may have to be a bit more careful about any data loss. So you want to make sure that you're not actually dropping columns that had data in that you cared about. So you might have to add some extra steps into to manage that. Something else you might want to consider is testing different database engine versions. So say if your database is SQL Server, you may want to have available different installs of 2008, 2014, 2016, 2017, 2019, cloud version as well, just to make sure that your database works on all the different versions. So how are you going to do that? Is there ways you can spin up databases, or do you need to license those? Moving on to unit tests. Unit tests, obviously, it's great to have as part of our build process to validate things are working correctly, but sometimes our unit tests can fail, and it might fail on the build server even though that's passing locally. So what are some reasons why that can happen? Well, a really common one is region or time zone or formatting differences. So I've got some quick examples here. I'm just going to bring over Visual Studio, and we've got a few different code samples where the code, the way it's being tested, means that these tests are likely to fail inconsistently. So first of all, we've got a sample here where we've got some logic that's based around dates, and basically if it's a Boxing Day sale, so the day after Christmas, our discount is going to be different to every other day of the year. If we've got a unit test around this, then this test is probably going to pass for every day of the year except for potentially Boxing Day. So we might need to think about how can we rewrite our code so that we can test this properly. Second example is basically formatting. So we've got some dates here. Now, if I ran this code where I live in Australia, then this would probably be fine because all these dates would work. But this third date here, if my build agent was in the US or somewhere else where they tended to put the days and the months the wrong way around, or a different way around, should I say, then it's going to be pretty unhappy about trying to convert that to a date. So that may actually fail, whereas actually it was working fine on my computer. And likewise, another example where we're making assumptions about what day it is and when we're adding days. So again, these kind of things can go wrong when we're making assumptions, particularly around if the year has a leap year in it or not. So there's an extra day in February. So you might add some days, or you want and sort of jumping on ahead, and you end up with a different day. So dates and days can be really problematic in our tests. So it just needs a bit of extra care, and not necessarily just assuming that using the sort of datetime.now or whatever the equivalent of that is in your code. Another thing that can happen with our unit tests is that we might actually have missing dependencies. So we may have something installed on our own computer that isn't installed on the build agent, which causes that test to run in a different way. Or our desktop might be a lot faster than our build agent, or maybe the other way around. Maybe we've got a really crummy laptop we're doing our development on, but the build agent runs a lot faster. So the timing could cause tests to fail. Yeah, just something to be aware of, to not make assumptions about that. Moving on to integration tests. If we want to test with other parts, so it's not just a unit test, but say with a database, how are we going to do that? The difficulty with testing with a database is the test becomes a lot slower. So we might go, okay, well, we might be able to use an in-memory database. That might be faster. So for example, if we're using Entity Framework Core, there is an in-memory provider there that we could use. The trouble is it's not exactly the same as using a real database like SQL Server or MySQL. There will be differences. So if that's our only way we're testing, where there's a risk that we might not be seeing some problems that we're then going to experience when we try it in the real environment. And yeah, a real database is a lot slower. So really you want to think about trying to do as fewer tests as you need to with a real database, just because it's going to take a lot longer to spin up a database. But then if we've got a database, well, how do we populate it with test data? Are we going to load that test data each time? Are we going to do some kind of restore and a backup? Or are we going to use a backpack for a SQL Server database, for example? There's different options there. And then is that data going to be persisted between tests, or how are we going to do that? So are we going to rely on transactions to be able to roll back the data? Or do we need to say, do that backup and do a restore each time we run a test? That's going to take a bit longer, but it's going to be a bit more reliable. So the transactions might be okay, but maybe we're doing something unusual with the database that the transactions actually don't work for us. Things to be aware of and take into consideration. Something else we need to think about is managing our dependency changes and being intentional about that. Don't just let it happen and then suddenly discover that things are broken. So for example, when we do our package upgrades, be intentional about, okay, I'm going to upgrade this package to a new version, let that run through our build system, run all our tests and confirm, yep, everything still works correctly, or, oh no, there's been a regression we weren't expecting. We'll need to figure out why that is the case. Is it a problem with the library, or is it a problem with our code that we need to fix? But likewise, with tooling upgrades, if we want to jump to the newest version of our programming language, so say for example .NET, we want to adopt .NET 5 because we want to use the nice C# 9 language features. It might be just a simple process of just updating our projects to say that you want to use .NET 5 and everything works, but there might be some breaking changes. So again, be intentional about saying, yep, I want to adopt .NET 5, for example, and then test that out. I know in some software I'm working on, there's some breaking changes in .NET 5 that mean that I'm going to have to change our build process because of the way things used to work in a previous version of the SDK will not work the same way anymore in .NET 5. So if we're really concerned about wanting to have a consistent build and runtime environment, then Docker might be something that comes to mind. And it's something I've certainly looked at using to make our builds more consistent and reliable. So the thing I like about using Docker is it means I can be a lot more specific about the exact tooling that's being used to build our software and run it as well. It also gives us the opportunity to build cross-platform. So even though I'm sitting or standing in front of a Windows box here, I can bring up a Linux Docker container and do builds there and test out that as well, running under Linux. And so I can build for Windows and Linux and for other environments too if I wanted to. And because I've got a Docker file that defines what's actually going on inside that container, I can be pretty confident that I know the tooling that's there and what's happening. And I've got a bit more control than if it's just a VM and I don't know that someone else has come in and installed something or changed a version of something. The other nice thing about Docker, and sort of we talked about caching earlier on, is that we can leverage layer caching to improve performance. So if we've got our build happening inside of Docker and we've staged our build in the right way, if we run our build a second time, it can realize actually you didn't change any code, you just updated the README file. So my compilation, I can just skip all of that because it's exactly the same as it was before, and our builds become a lot faster, which is nice. Something to be aware of if you're using something like Docker Compose is that it doesn't define the dependency order when you're building images. So Docker Compose files, we can indicate the dependency between containers, but if we want to build those containers, we might need to use another tool. And one that I've used is called Dobby, and it has a different configuration file where I can define the images and the order in which those need to be built, particularly if there's a dependency between one image and another. And also sometimes images might disappear. So Docker images, and this I guess is a reality now that Docker Hub have announced that they're not going to keep images up in the public sort of free offering forever, particularly if they haven't been used for a while. So if you were depending on an image being around and you hadn't built it for a while, you might discover all of a sudden that it's not there anymore because Docker have dropped it because you're not paying the money. So caching, we've talked a little bit about it, and it really can make a difference in the performance of our builds. So a few quotes about caching. There's the quite well known, there's only two hard things in computer science, cache and validation and naming things. Or the variation, there's two hard problems in computer science, cache and validation, naming things, and off by one errors. And I guess the challenge here is knowing when to invalidate our cache. So if we're using caching for our builds in, say, GitHub Actions or pipelines, being sure that we've got the configuration correct so that the build can determine, oh, you've changed stuff here, or you've got some new packages you're pulling in. I can't use the cache, I need to invalidate that, and I need to download these things. So making sure that's set up the right way. Something else I like to incorporate into my build process is static analysis. So there's a whole lot of different kinds of tools we can use to investigate our application and let us know if there's any issues. So there's some security scanning, and so for example, Microsoft have some tasks that you can add to your Azure Pipelines build to do all kinds of scanning of your source code and looking for known vulnerabilities or APIs that you shouldn't be using. We could introduce linting, so things like ESLint for our TypeScript or JavaScript, so that we can define the way we want our code to be laid out and to avoid particular patterns that could be problematic. And likewise, if we're into .NET, we might want to use Roslyn analyzers again to let us know of particular issues in our code that we want to avoid. We can even write our own analyzers or linting rules so that we can start to incorporate our own business rules into how our software should be written, which is kind of nice. Thinking about deployments, if we're going to deploy our software, there's many different ways we can do that. I guess some of the more popular things are just like an Xcopy or a zip file or an MSI, or we want to deploy it into an app store. Well, how do we get that file into some of those locations? Well, there's tools we can use to do that. So we could do a right-click deploy, and if our application was just a little throwaway thing that really didn't have a long life, that might be okay. But usually you want something a bit more sort of process oriented. And so a tool like Octopus Deploy or release pipelines, or there's some new features coming in GitHub now as well, to add a proper process around how we release our software can be really useful, so that we're a bit more organized and that we can actually manage that. It's not just one person who can do it, but it's an automated process. We can reduce those manual steps and reduce the chance of error. But there is some things that can happen that can surprise us. So sometimes we're trying to deploy software and the target machine may be offline. So an example of this was where I was deploying software that was being sent out to locations out in the country. And it turns out that these locations, because it was the middle of summer, they had air conditioners to keep them cool in the day, but when they went home to save power, they would turn the air conditioner off. And so the server would overheat and shut down overnight. So when we're trying to deploy a new version of software, the server wouldn't be running because it had shut down due to overheating. So that was not something I'd anticipated. I just assumed that all the machines would be running all the time. So you may need to take those kind of things into account. Or what happens when hardware needs to be replaced? Is there a way to do that, or is it virtualized so that it's less of an issue? Or what about when there's too many files to copy? Again, something I ran into a while back when we were doing a server migration. We thought this migration was going to take an hour or two. It ended up taking almost the whole day, because it tended there were lots of small files, and lots of small files take a lot longer to copy than a few large files, just because of the network overhead. And so think about that. Maybe you might need to zip up all those small files, copy that zip and then unzip it. That may be faster than just trying to copy them all individually. Or what about if you've ever had to try and deploy some software manually through about 2 or 3 nested RDP connections? That is a pain. There's not really any way you can automate that. It's probably a discussion to have, particularly if it's to with a customer that's got that kind of environment you're deploying to deploy the software to. And particularly if they've got restrictions about like drag and dropping the software into the RDP session, or accessing something like OneDrive or some other website to get the software into the machine. You may have to sort of make multiple jumps to do that. There's just things to be aware of, that not everything can be automated all the way through. So sort of wrapping up, think about how you can simplify your build and your deployment processes. Often things will evolve over time and they may become more complicated. So it's always useful to think about, actually, is there a way I can simplify this? That's not just for other people to understand, but it's often for yourself in a few weeks' time when you come back to the build and you go, I don't understand what's going on here and I wrote this. So if it's simpler, then it's probably going to be easy to understand. Look for opportunities to reduce waste. And so, for example, if you're rebuilding the same thing multiple times, that's essentially waste. Why are we wasting our time doing the same thing again? Is there a way we can just do something once and then reuse that effort? Always look for opportunities to automate. It just reduces that chance of error and it makes things more reliable. Also iterate over things. So just make a small change, try it out, see if it works better. If it does, use it. If it doesn't, then you've learned something, and then try something different. And yeah, look for those quick feedback loops. And so one of the advantages of having an automated build and deployment process is that we can include feedback as part of that. We can find out quickly if something is not working. We can even go to the extent of including the sort of telemetry in our application. So once it is deployed, we can monitor it and monitor it for problems in production. But also as part of our build process and our deployment process, being aware, is something taking a bit longer now than it used to? Has something changed? And being able to act on that is really useful. So sort of doing all these things, it is a continuous process. These are the things I've come across till now, but I know there'll be more things in the future that I haven't seen before that I'll need to take into account. But hopefully if I do all that, I'll end up with harder, better, faster, stronger builds and deployments. So thank you. And if there's any questions, feel free to post those into the Q&A, and I'll be happy to take them. Otherwise, thanks for coming on to the talk, and really appreciate your time, and I hope you enjoy the rest of the conference.
Thanks for the good presentation there, Dave. Yeah, we don't have any questions at the moment, so anyone want to post any quickly? But yeah, certainly. Otherwise, yeah, thank you very much. It's a great presentation. Sadly, you don't get any round of applause because there's no one here. So I've been doing a little clap myself, but it sounds completely pathetic. So there you go. Cool.
That's all good.
So see you.
Yeah, no, thank you.
Okay, so yeah, thank you very much, everyone, and yeah, see you about.